Well, I've had the pleasure of working with the gentleman I'm going to introduce now on the radio direction finding stuff. I've had the pleasure of having off-the-air conversations with him about various things. I really enjoy Doug Chandler, W2BX. He's a great mind. He's a great person. But when I asked him for some bio information, because I'm not sure all of us know him that well, I learned a lot of things I didn't know about Doug. He was born and raised in Iowa. He definitely has unlimited talents and hobbies. And among his hobbies include photography, drafting, woodworking, mountaineering, spelunking. I guarantee you, Doug, I'll never do spelunking with you. Canoeing, rocketry, electronics. And then the last one kind of baffled me. He put down girls. And I thought to myself, we better change that to women. Girls didn't sound very good. So I changed that one, Doug, just to protect you. He has a degree in chemistry, minors physics, and computer science. He's been employed by DuPont. Then he moved to Silicon Valley and worked for a lot of startup companies and software. He's been a ham operator since 2018. He's married to Teresa. We've had the pleasure of meeting Teresa. And he has 3 lovely adult daughters. And at that point, Doug, I ran out of room on my page of paper, so I'm done. I'm going to turn it over to you, TC6 SLA.
Thanks, Graydon. Almost all of those things were lies and exaggerations. I did enjoy growing up in Iowa, though. So in November, we started talking about batteries, and we sort of ran out of time. So this is, we're going to do a couple of things here. This is batteries 102, and I always like to start out with be kind to your battery, and it'll be kind to you. No matter what battery you have, take good care of it, okay? Batteries get abused. Let's see. Okay, I think I do this. Okay. Okay, so last time, this is a summary of what we talked about last time. This is what I think is the key point. Lithium iron batteries are affordable now, and in fact, they're more affordable than lead batteries. So if you ever had any question about, what should I do if I'm buying batteries in the future? The idea is the chemistry du jour is what I call LiFe. Lithium iron phosphate batteries. And at the checkout counter, you may not feel like they're cheaper when you first look at them, or if you're hunting on eBay or Amazon or whatever in order to buy your batteries. It looks like they're considerably more expensive. However, if you do the math, it turns out that if you compare the number of recharge cycles that you'll get out of a lithium, out of a LiFe battery, and also take into consideration the depth of discharge that's available, and if you compare, say, a 50 amp hour lithium LiFe battery, it'll deliver the same amount of power as a 100 amp hour lead battery. So that's one of the first leveling criteria for these things, because the depth of discharge on a LiFe battery is 90%. And that versus a lead battery, which you can really only discharge 30 to 50% if you're going to use it correctly and expect it to last long. If you discharge your LiFe batteries 90%, you can generally get about roughly 5,000 recharges out of a lithium iron battery. Compare that to a lead battery, where if you discharge it 30 to 50%, you'll get about 500 recharges out of it in its lifetime. Now, lifetime is a little bit, there's actually a technical definition for a lifetime of a battery. It's not when it's dead, it's when it's 80% depleted, and it will no longer charge more than about 80% of its rated capacity. So properly cared for, Life batteries provide at least 10 times the total energy delivery over the battery lifetime. And that means up to 80% of its original capacity. So they're actually a pretty good deal. Here it is in graphical detail. The battery on the left is obviously a lead. It's a 100 amp hour battery. Sorry, yeah, no, I got the wrong thing here. This is actually lead over here. So forget the LiFePO, but this is lead, and it's a 100 amp hour lead battery, but you should really only discharge it into this green zone, which is about 40 to 50%. And down below, you really don't want to routinely discharge down into the bottom part of this battery. So you can go out and you can buy yourself a Life battery or a lithium iron battery. And if you don't charge it all the way to the top, which is a really good idea, and you just use the 42 amp hours in the center, don't discharge it all the way, only discharge it to about 90% of its capacity. You'll get the same amount of power out of a 50 amp hour lithium battery that you get out of a 100 amp hour lead battery. And in the lifetime of these batteries, you'll get, for lead, like I say, you'll get about 500 cycles if you don't discharge below this green zone routinely. And in a lithium battery, you'll get about anywhere, it depends upon what the manufacturers say, but you'll get somewhere between 2,000 and 5,000 cycles. So that means you'll get 120,000 amp hours out of it compared to a lead battery where you'll only get 20,000 amp hours in its lifetime. This just goes to show that you can actually go out and search for sort of medium grade batteries that are either lead, which is on the bottom here, or lithium, ferrous batteries that are on the top. They're coming out to be about the same price at the checkout, and you get a better battery if you go with lithium. Now, how do you be nice to your battery? If you take good care of your battery, it'll take good care of you. This is my code of being good with batteries. Always use a quality charger. You know, spend the money and get a quality charger that has a charging profile which is specific to the battery chemistry. You can do things like, use an old lead charger, battery charger to charge up your lithium batteries. But if you do that routinely, your batteries won't last as long. The other thing to do is install fuses, and install the fuses as close to the battery as possible. All you have to do is just have a short circuit once or twice on batteries that aren't protected from shorts. And if you don't have proper fuses installed, I would install fuses even if I had a battery that was protected for shorts internally, because it's an extra safety factor. The other thing is, don't routinely charge to full capacity. On a Life battery, the thing to do is charge to 90%. I wish I had known that when I bought my electric car, because my battery would still be substantially better shape than it is now. Never discharge below about 85%. Don't do a rapid discharge, because rapid discharges generate a lot of heat. If you're if you've got a 50 amp hour battery and you're discharging 25 amps or more, you're going to generate a lot of heat, and heat is the enemy. I mean, heat kills batteries. And the higher the temperature, the quicker the battery degrades. The same thing goes for rapid charging. And anybody who's got a cell phone and they love to rapid charge it, don't do it. Let your batteries have time to charge. Let them dissipate the heat and give them some time to charge up. Don't operate these batteries in temperatures outside of about 35 degrees to 100 degrees Fahrenheit, or whatever the manufacturer's spec is. They don't do well in extreme cold. In fact, anything below 32 degrees can seriously damage your battery. And anything above 100 degrees, especially if you're discharging rapidly or charging in an environment over 100 degrees Fahrenheit. And don't store your life batteries fully charged. And why that is, it's a little bit of homework for you. Never, 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 ever discharge a lithium iron phosphate battery fully. If for some reason you don't have other types of protection to keep your battery from discharging completely, monitor it closely, because if you fully discharge it, you may not ever get it to charge again. So what we're going to do is just talk briefly about the new topics, which are chargers. I'm going to do a flyby on that. State of charge monitors, which basically tracks the charge and discharge for a net charge. It's a way of telling how much charge is left in your battery for life batteries. And the reason that it's important to have a state of charge monitor is you can't just put a voltage meter on one of these and figure out how much charge is left in it. We're going to talk about a few highly featured battery management systems, and what the typical features are of a highly featured battery management system. And if time permits, we'll talk about voltage cutoff monitors, which are good for lead acid. If you've got a radio in your rig, and for instance, and you want to leave it monitoring, or you've got a crossband repeater in it and it's drawing juice off of your battery while you're not at your vehicle, sometimes it's really important to have a voltage cutoff monitor that'll shut off the power to the radio when the battery gets to a certain voltage. That way you have some juice left over when you come back to get in and start up your vehicle. So I'm not going to go into detail about chargers per se, other than to say there are zillions of battery chargers available for lithium iron phosphate. The chargers do two things. They control the charging voltage and the current profiles, and they do that to reduce heat and sort of warm the battery at the beginning to a constant temperature throughout. And you want to get a charger that is specific to the battery chemistry. A lot of the chargers will do, lead, lithium iron phosphate, lithium gels, and all kinds of stuff, but you want to make sure that it will do the battery chemistry for the battery that you own. And this little chart down here just shows the 4 stages of some of the smart chargers. Some are 6-stage smart chargers, and we'll take a look at a couple of examples of that. Here's a very reputable source. Victron makes a fabulous lithium iron phosphate battery charger. And it's also versatile, so it'll charge just about any other chemistry for you. Now, on the practical side of chargers, the first thing that people frequently ask me is how big of a charger should I buy? Should I buy a 50 amp charger for my 50 amp battery? And my answer is, well, it kind of depends. If you need to charge your battery in 1 hour and you've got a 50 amp hour battery and you get a 50 amp charger, theoretically you can charge your battery in 1 hour. But do you really want to do that? And why wouldn't we want to do that? Well, because of heat. If you don't need to rapid charge your batteries, don't get a charger that charges your batteries at a high rate. If you buy a 5 amp charger and you got a 50 amp hour battery, but you've got 10 hours to charge your battery and you never have to really charge it any quicker than that, then the thing to do is buy a 5 amp charger, and that will produce the lowest temperature in the battery as it's charging. And heat's the enemy. So you might want to go for something that gives you a little bit of versatility, especially if the charger allows you to derate or to set a lower charging amperage. So I went out and looked at this Victron, and it came up and said, hey, you can buy a 12 volt, 5 amp charger for 77 bucks. And you can use your smartphone to program the charger, and you can check the state of the charge on your battery. And that's a quality charger. There's a few caveats. Lithium batteries are really sensitive to under voltage and over voltage conditions. And some of the chargers know how to deal with lithium overcharging and undercharging protection devices that may be incorporated into the batteries. Some don't. And so what this is saying is some reverse polarity protection chargers will not recognize a battery when the UVP is tripped. So when you're out looking at battery chargers for your lithium iron phosphate battery, one of the things you want to look up on the spec sheet is just this. If you've got an issue with UVP, then you want to find a battery charger that will automatically reset the UVP and restart charging. So it's more than just going to Amazon, clicking on there and saying, I want a lithium iron phosphate battery charger, picking the one that's 44 bucks, pushing the button, because it may not do what you want it to do, and you may actually end up damaging your batteries. So how do I charge the batteries in my shack? Well, I have a solar charging station, so it pretty much takes care of everything. I don't have to think about anything on my batteries. I hook it up. It's got a solar MPPT for taking in current, from my solar panels. It'll take up to 40 amps, but it will also derate, so I can charge my batteries slower. And it is currently charging 150 amp hours of lead long deep cell batteries. And I never have to think about it. It just keeps them running. And they've been sitting there for 5 years and they're in great shape. Now, the cost of one of these is I don't know, 250 bucks, something like that. But you can buy chargers that pretty much take care of everything, and including connecting solar panels. So another approach to battery management systems, a little less involved, is a state of charge monitor, or an SOC. And an SOC really does one thing. It's, let me see if I could use an analogy. State of charge is, if you think of your battery as a gas tank, it's got a certain amount of gasoline in it, and you're discharging, you're burning up some of the fuel. What the state of charge meter does is it keeps track of how much fuel you're burning, and it can tell you at any particular point what that is. And at the same time, you may be getting some fuel put back into your tank. And so it measures the amount of charge that's going back. So getting rid of the analogy, we're basically looking at the net charge and the net energy inside of the battery at any particular point in time. And so we know exactly how much charge there is in the battery, and we can also set some alarms on the state of charge monitor, so that if the battery got down to 25% of capacity, it could set an audible alarm or send a message to your cell phone and let you know that your battery is at the alarm level. Now, state of charge monitors come in different levels of accuracy. You can spend a fairly good deal of money on a state of charge monitor. And sometimes it's worth doing that, because some of the cheaper monitors that I've torn apart end up having componentry in them that isn't the highest quality. And if you do 100 cycles of recharging with a state of charge monitor, and the components are off more than 0.1%, you can end up with a 10% error in the state of charge. And so it's important every once in a while, if you buy these state of charge monitors and you're relying on them to let you know exactly how much power you still have left in your battery, you need to reset them occasionally. Here are some examples that I pulled off of Amazon. Prices vary all over the board. The features that are available are all over the board. If you got the money and you just don't want to worry about it, but you want a state of charge monitor for your batteries, the Victron Energy state of charge monitor is definitely the way to go. I have a couple of $35 state of charge monitors that have really nice componentry in them, and they're perfectly adequate for what I do. So if you buy a lithium iron battery, typically these batteries now come with an integrated battery management system. And the features that are available in a battery management system, an integrated battery management system, varies widely. However, they pretty much all have a charge and discharge voltage profile that protects the limits of charge inside of the battery cells. So you can neither overcharge your battery nor drain it beyond the lower limit. Some have temperature sensing. So the battery manager inside of the plastic case that holds the cells themselves also have a thermometer and it'll keep track of things like what is the ambient temperature, what is the current temperature of the battery as it's charging. And if you exceed the limits, either on the cool side or on the hot side, it will shut down the charging cycle. And in some cases, as soon as that temperature goes back to acceptable limits, it'll start the charging back up. More common is a cell charge and discharge balancing circuit, because inside of your 12-volt Life battery, there are 4 cells, and they do discharge and charge at different rates. And there are electronics inside of the battery management system that equalize those charges out and make sure that the cells are balanced and charged. You can get monitors and alarms that will fire off messages to your cell phone through Bluetooth or Wi-Fi. You can get some that have serial connections or Ethernet. And the list goes on there. I mean, pretty much, if you look around, there are all kinds of gimmicks and gizmos. For me, I like to stick to the basics, but one of the things that comes up here on a regular basis for me is, well, should I buy a battery that has a dedicated built-in battery management system, or should I buy raw cells and buy my own battery management system, external battery management system? And the answer to that for me is, if I'm dealing with over 100 amp hours, it might make sense to have a external battery management system that can do just about any of the selectable battery chemistries. And of course, you can get integrated MPPTs so that you can hook up your solar panels to do the charging, and you can manage single or multiple batteries. This is just a diagram of what a battery management system looks like. This is one that I purchased in the past. It's a 5-cell, it says 21 volt, 100 amp wiring diagram for one of these. It's, I don't know, 2.5 inches by 2 inches, maybe 3 inches by 2 inches in size. And what it's showing here is that the charger and the load are connected. The cells that are inside of the battery case or outside, depending upon how you've got this set up, are connected in the way that it's showing here. And this thing with a microcontroller on it pretty much does all the work of managing and protecting your battery. Whether you get a battery management system that's included in the case with the battery, or you get one which is external, and you're buying, let's say you're buying the battery, make sure, and you want to know what's going on, always look for the data sheet. Before you buy, look at the data sheet, look it over, and if there's things on it that you don't particularly understand, do some research. In this particular case, this is saying we've got overcharge protection, we've got over discharge protection on an individual cell basis, we've got over current protection, we've got short circuit protection, we've got temperature monitoring, and you know, that's a pretty nice list for most purposes. So here's my personal opinion preferences. Under 200 or 100 amp hours, keep the BMS simple. If you can find a good battery that's got an integrated BMS and it's got the basic features, especially charge limits and short protection, some kind of a thermometer and temperature compensation or temperature shutoff for charging and discharging. If it balances the right number of cells that you're going to be using, you probably have enough. If you want convenience, there are other factors to consider, like, is it going to provide you with alarms that come to your cell phone, or integrate into a computer system that can monitor more batteries? Then you need to look for those specific features. Most lithium iron phosphate batteries that are 12 volts can be connected in parallel, and the integrated battery management systems work just fine. So if those battery managers are for the same battery type and manufacturer, you can generally get away with hooking two 50 amp hour batteries in parallel and getting a 100 amp hour battery. However, integrated battery management systems are generally not recommended for serial configurations. And if you're considering buying two 12 volt lithium iron phosphate batteries that have battery management systems in them, right? Check the spec sheet for the battery before you do it, because few will actually support that. So if you need a 24 volt application, it's best to just buy a 24 volt battery. So let's see. I have time for one more slide, but I do want to point you at YouTube. Some of the best information that I've got about what specific battery managers, batteries, and accessories to buy is on YouTube. Will Pros has an excellent channel, and he tears apart batteries, battery managers, solar MPPT systems, and he rates them, and he does an excellent job. And there's also a company out there called Solar Solutions that does the same thing. Spend some time watching YouTubes. And just because we have a second, for those of you who have mobile units and you want your battery not to end up being dead if you leave your radio on in your vehicle, these little voltage disconnects for lead acid batteries are nice. They're not perfect, but they are nice, because you can hook these in between your battery and your radio. You can set a reset voltage, which is this green line. You can set a disconnect voltage, which is lower than the reset voltage. And as the voltage of the battery drops down in here, which is this blue line, if for some reason you push the talk button and it clicks and you get a voltage drop and it drops below the disconnect, it's going to shut off power from your battery to your radio, and it will not restart. It will not reset, should I say, until the voltage has swung back up above the reset line. That's one of the issues with these. The other issue is that they have a parasitic load of about 100 milliamps, and so you can't leave them unattended for long periods of time because they will drain your battery. There's a relay on these, and there are LEDs that are drawing current at all times. So my recommendation is, if you happen to buy these, always install a disconnect and put this in as close to the battery as you possibly can. Okay, are there any questions?
I have a question.
Yes.
All right, multiple questions. Rob here, KM6YKX. Would you say, I think I know the answer, but that in these life batteries, iron phosphate, that there still are differences between a starting battery, like the one in my motorcycle, which I have a second question on that, and a deep cycle version?
You mean, is there an equivalent of a starting battery and deep charge for lithium iron phosphate?
Yes.
No, there isn't. Not that I'm aware of.
Okay, so like theoretically, the one that I use in my motorcycle, I'm pretty sure it would work just the same for a radio.
Yes.
It's like, okay, interesting. All right. So I'm fascinated by them because they're very light. The one I have is very small. So my second question is, because I've destroyed a few of these and they've been in extreme environments, but the reason they've gotten destroyed is because I forgot to turn off the key. And then I could usually get them to come back to life through various methods for a while. But one of the things that I've had to do on multiple of them is I have a LiFePO charger, but it wouldn't recognize the battery if it was too depleted. But then if I jumped it with a different charger, which I tried to use the lowest possible power, and it would recognize voltage, and then the LiFePO charger would start charging it. And then, I'd get the other one off there, and, I could get some more life out of it until I killed it the next time from my parasitic drain problem, which I'm still chasing. Do you have any thoughts on that whole, you know what I mean? Maybe that was what you're talking about, under voltage protection, and, how to like come back, little CPR.
Yeah, and that's actually a feature of the charger. The way that I've gotten around that, I mean, once you really discharge those things all the way down to pretty much nothing, you've damaged them. They will come back to life, and you will get some service out of them. But they're pretty injured. You can take the battery, and you can get a bench charger, just a regular DC bench voltage, DC voltage charger, and hook it up and put just a small amount of current and maybe 5 volts into it, and just let it sit there. And eventually you will be able to charge it with your regular charger.
Okay. Yeah. Well, I mean, I've been in, each time I've caught it at a certain point, I mean, it's a problem with I think I've identified the relay on the motorcycle that's sucking it dry. And anyway, yeah, I've been able to get away with it, but I recognize that discharging it damages it. So
yeah, so here's the real recommendation. When you have to buy a new battery, make sure that it's got a battery manager in it, which protects it from undercharging. I mean, from over discharging.
All right, perfect. Thank you.
Hey, Doug, I have a question for you.
Go ahead, Eric.
Yeah, this is okay. Eric over here in Auburn, KJ6TLD. What is your take on absorbent glass mat batteries, which seems to be the lion's share of what we're going to see in automotive and motorcycle applications? What would you recommend for charging if they're not being used for any elongated period of time?
I don't know. Does anybody have an opinion on that? I really don't use glass mat, so I don't know.
Okay, and the only reason I ask is because I use AGM batteries in my motorcycle as well, but I've recently moved over to the lithium ion batteries, which is a totally different charging schema for those. But I'm just used to using the old school maintenance free batteries, which seem to be AGM for the most part. So I was just curious if if you had done anything like that in the past, or what you would recommend.
Well, the batteries that I have in my shack are actually flooded lead batteries.
Okay. Okay. You're using the old lead plates and the acid, right?
You betcha.
Okay. Okay. Cool.
Eric, I can give you an idea of what I do on my collector cars when I have to store them for a period of time.
Okay.
I use a device made by Battery Tender. It's a very low amperage, 800 milliwatts, but I put a battery tender on them, and it does a good job keeping the battery. It really makes up for the internal loss in a lead acid battery caused by the internal resistance.
Okay.
And, keeps it at a steady state. Every once in a while, it'll give it a little bit of a boost, kind of like an equalizing charge.
Okay.
So you might check it out. I've had good luck with a brand called Battery Tender.
Okay.
Got them from Summit Racing. They work really well.
Okay. Okay. Yeah. I was just curious because, yeah, like I said, I use all the old school stuff, and the only thing new school is in the motorcycle, which I haven't even put in the battery box in the motorcycle yet. So, yeah, so I'm just trying to figure out, different options, to maintain the current batteries I have in the vehicles at the current time.
Yeah, so Eric, I can actually comment sort of in generic terms.
Okay.
Almost all lead batteries, when they're stored, you want to float them.
Okay. Okay.
However, but lithium batteries, you don't want to float.
Okay. So floating, is it float voltage 12.8 volts? Is that what you're saying? Or is it?
It depends on the battery, 13.8, 13.6. I've got two AGMs that I got for backup for power outages and stuff. And I asked the sales droid what the float voltage is. They said 13.8. And then you go and you look on the spec sheet, and no, it's not. In fact, they're different. Yeah. One's a 55 amp hour AGM, the other one's a 92.
Okay.
92 is what I use to start my fridge.
Okay.
Now I'll comment about that in a second, but one is the 55 is 13.65, and then the 92 is 13.4.
Okay.
According to the manufacturer. So push on them to get with the manufacturer.
Okay.
AGM, SLA, deep cycle, all that kind of stuff, but they're different.
All right, I have a big comment, but I want to make sure that Jeff has the floor to make sure, are we moving along, and we can take this after that. But yeah, I have a big comment on the battery. I'll hold it till later.
No worries. Yeah.
Let me finish my second comment though. Is
Yeah.
on the lithium batteries, check again the spec sheet for the surge current that you can pull from them.
Okay. Okay.
Making amps kind of a thing.
Yeah, so that'd be your max amp hours, correct?
Actually, not just lithium, all of the batteries.
Okay.
The 55 that I've got doesn't have a cold cranking amps rating on it, and you pull a lot of pull a starting current on it for from your inverter just to run your fridge. The fridge draws think about a kilowatt and a half for a second when it starts up. Okay. And so the 92 amp hour has a cold cranking amp. It'll run it. The 55 doesn't. Not all lithiums have a high cranking amp rating on them, and so that one is big enough.
Okay.
The surge current. They call it a surge current.
Okay.
For the battery, and just check the specs. There's a lot. There's a lot to these things that I mean, Doug has done a great job, but it's still a lot still under the covers there.
No.
I have a comment.
Go ahead.
Be careful about these battery tenders and the battery chargers. They're RFI generators. They're switching devices.
Switching power supplies, right? Yeah.
Yeah, and I have a couple battery tenders on my tractor battery in the garage away from the house, and I have to go turn that off when I operate 40 or 80 meters.
They start splattering on your receive, right?
Wipes you out.
Okay.
I think we should have a discussion on the elmernet about batteries and the coming elmernet too.
That would be great. That would be a fun Q&A.
I invite everybody to show up at the elmernet and we'll talk about batteries.
Fair enough. Yeah, let's move on. I don't want to hold everybody up. I was just curious, guys. Thank you very much.
Okay, let's take one or two more questions and then we'll turn it back over to Jeff.
I just had a quick question. And Eric, first of all, Doug, thanks for the presentation. It's just a lot of great information, but there's great minds here. You were talking about, I think Rob and Eric were talking about interchangeability with the lithium iron batteries in some of the more automotive applications like motorcycles. But I've always been worried about the specific charging needs of these batteries, not only the cold cranking amps that Greg brought up, but how does the charging mechanisms differ? Can we assume that these batteries will charge okay in a direct swap, or do we have to?
I think we can assume that they are not going to charge well under the conditions of being put into a vehicle unless they have the right battery management system involved, knowing that they're going to get charged from a source like a motorcycle or an automobile.
Yep,
All right.
and I wanted to add, Graydon, thanks for that battery tender plug. I think Costco has them for about $40 for the 4.5 amp. And I find that it does it very efficiently, regardless what type of, whether you're running lead acid or the lithium iron, right?
Show up to the elmernet and we'll talk forever about batteries, because there's a lot of things to talk about when it comes to batteries. If nothing else, I hope that the following messages got across. Lithium isn't just a drop-in replacement for lead in all cases. You have to take care of them, and the thing that will destroy your battery faster than anything is extreme temperature conditions, right? And some of those are induced by, the environment, and the other ones are induced by how quickly you discharge or charge your batteries. And so be kind to your batteries. If you have an application where you need to be able to draw large amounts of current, get a bigger battery, because the battery has more mass, and as it discharges or charges, it spreads that heat out into the mass of the battery, and the temperature doesn't go up as high, and so your battery will last longer, right? Or buy several small batteries. Anyway, Jeff, I think I'll turn it back over to you, and we'll get together on the elmernet and have fun talking about batteries there. Thanks, everybody. Really appreciate it.